Cool, so first let's demonstrate a principle. That's probably going to be a bad example for the next thing we're going to demonstrate. So I'm going to make a tree myself and hold on to your hats, because this will blow your mind. Scale it up. God, look at that. Now that, ladies and gentlemen, is a tree. And to demonstrate its treeness, it still occludes the character, so we still need this problem sorted. So okay, so the principle here is about the grid, that a sculpt knows if it's been detected over here. So if you watch that and you turn the trigger zone onto label mode, you can see it's flashing because you have this tweak menu open. So it knows that it is possible to be detected. So if we see that, because the zone is touching it, then we get a detected signal. If it's not touching it, it doesn't get the detected signal. So we can use that to our advantage. So for now, I'll just grab that, put it into here, put it into modulate using L1 and X. So modulate means this value is multiplied by the incoming value from the wire. So it's not being detected, and then if we make it detected, then it glows. So if I show that again, now that, okay. So let's use that principle. So we have this like that, and what we could do is just make it really long and really thin. So let's go into here to make sure it's still round. So just make it 0.1. So it's like a tiny thin trigger zone going all the way over there, based on where the camera is looking. So let's do, whoa, it's even harder without the pointer, isn't it? Let's put that pointer on. Okay. Oh, you can't get those. Oh, it's not got the label, the mode. There you go. So then we have look at rotator, and that end is going to point at the player, and also have the trigger zone coming out of that same angle. Okay, so let's go over here first. It's already glowing for some reason. That's not what we want. Oh, because we left that. Okay. Okay, so let's go over here. So now, if we just play time, it will still follow and try and look at the thing. And it's flickering. Oh, 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 oh. Yeah, I know what that is. So what's happening is it's looking for a visible sculpt. It finds a visible sculpt. The visible sculpt becomes invisible. It can no longer find the visible sculpt. So we'll put that onto both. That is probably the issue we were having before. So now, because the trigger zone is so fat, it's causing issues. Oh, so let's try it like that. So hides when it gets in the way. Cool. But you'll notice a problem. When you look at it from the other side, it goes through, right through the puppet and to the other side, which isn't ideal. So we are going to I think for this, the quickest way would be to grab that, and we want to find the distance between the camera and the player and have the trigger zone only go up to the player and no further, so that it doesn't hide things on the other side. So so now we get a splitter. Let's get the scene space transform, and we get the position of this, which is actually the same as this up here, and we want to subtract the two. So we want to get the position of the player minus the position of the camera, and that will give us like a vector that is just from that pointing at that, basically. But we want just the length of that vector, which you can get. We probably won't need to use this method, but you can get just that by putting it into a value slider. Make sure you got the ranges enough that it won't like mess up the value, and it'll just spit out the actual value of the default number. I don't want to keep on saying value. So this is a fat wire. All fat wires seem to have a default value associated with them, and when it's a vector, which means like a collection of numbers, A, B and C in this case correspond to X, Y and Z in the position of the world. So this kind has a default value that is the length of the vector, or also known as the magnitude. So you can actually see this changing here. If I move further away from the puppet, it's getting bigger, and if I go all the way up to the puppet, it gets smaller and smaller until I go on the other side, and then it starts getting bigger again. So that's what we want. Now I foresee a problem. We will deal with it once it comes up. So we probably don't need to put it through here, because it'll just use the default value in this case anyway, but we'll put it through there anyway, just for demonstration purposes. So we'll have a combiner. What we're trying to do is set this Z value, which is the length of the trigger zone. So, but you can't just plug that in directly to the Z value, because it's like a three-way, it's like one of these vectors. So we need to make a vector with a combiner. So we'll put it on a 3 because there's 3 values. Then we'll plug that into C, which is the third value, so it'll set the third value, which is the Z value. But we'll need another value for these other two, which will be 0.1. So we'll just set that to 0.1, and we'll plug that in there, like that. So now this should be set to 0.1, that should be set to 0.1, and that should be set to whatever that value is. So let's plug that in there, and it doesn't quite work. Let's compare. So we've got 0.1 should be setting those, 14.3 should be setting that, but it's actually getting 1.4. This is because for some reason distances like this are divided by 10 effectively. So before we send it in, we need to multiply it by 10 to counteract that. So we'll just use a calculator. The cool thing is, if you plug that into a calculator, then it'll apply the operation to all the values in that fat wire and then send it out. So we can just have one calculator instead of doing it to all these separate values. So times it by 10 and plug that into the zone size. So now we have 0.1, 0.1 and 12.9, 12.9, and that all works perfectly. So cool. So now let's see. So if I play time, it will go to the right position. If I go here and then pause and then click on that, it's not getting to the thing. Let's try adding a tag, which should be the same as that, but it might not be. So let's copy that, plug that in there, and instead of using that, let's use that. So play time, pause, okay. Oh, that one's working perfectly. So I don't know what's going on there, but that's what you need to do. You need to use a tag, and again that tag is the point in the center, which is the same as the tip of the cone of the trigger zone. So now if you make that distance larger, we can see if it's working with the tree. So it's, let's make a bigger distance. Whoa. Okay, so when it's occluding, then it's hiding the tree, and when we're over here, it's not hiding the tree. Awesome. Because you'll be looking at it, especially if you have, I'll get to a point in a minute, especially if you have this camera pointer, then you know the angle it'll be at when it gets turned off like that. So what you can do is do that, surface snap, make like a somewhat see-through version like that for viewing from that angle. It's going to look awful. That is kind of less opaque. So, I can't. There you go. So now it kind of becomes this semi-transparent thing, and you could use that same keyframe. If the painting was off first, you could use the keyframe to turn that on, so the sculpt will become invisible and the painting will become visible. And you could fade that in or do whatever you like. So there's a couple of ways of occluding stuff and that, or of handling occlusion.